Mm-hmm. Yeah, it is 17.04, but that's fine. The increase in height. All right, great. Let's come to question number 2. You need to find the missing value of x, the compound shape in the form of various right angle triangle. You need to connect the dots here. Mhm. You can use the Pythagoras theorem, but for that you at least need to find this x and this y. Let this be t1, this as t2, this as t3, this as t4. So from t1 you can get this vertical height, which is sine 25 from t1. Sine 25 degrees equal to this vertical height. Let's call this as opposite, or name it AB. upon 167. So AB would be 167 times sine 25 degree, which is 70.577, so 70.6 meter to 3SF. So now you have this one AB, which can help you to get, let's say, CB. So we can use here from T2, I'll use tan 40 is equal to opposite, which we just got, upon adjacent, that is CB. So CB would be 70.6 over tan 40, that is 84.137. Now we have the CB. Come to triangle, this is triangle 3. Now let's take something from triangle 2. I need, let's put this as D. I need BD also. So for BD, I'll use again tan, because tan 38 degree is equal to opposite, which is BD, upon adjacent, which is we just got, we haven't got the adjacent, so I think we need this one as well, BE. Let's find out first BE. BE would be root under 167 square minus AB, which is 70.6 square, which is 151.34. So now we have the BE, so we can use the tan 38 now. Tan 38 is BD over BE. So tan 38 is BD, which is missing right now. BE, we got 151.3. So BD is 151.3 times tan 38, which is 118.2. Now we have the BD, we have CB, so we can use the Pythagoras in triangle 3. So in triangle 3, using the Pythagoras to get the x, which is CD, that is hypotenuse, so it is the root under of CB, which is 84.1 square plus B BD, which is 118.2 square, which comes out 145.065, 145.1, which we approximately also said 145 meter. That is the value of x. There are lots of connections you need to make to get the x here, but they are quite interconnected with ratios, sometimes Pythagoras theorem. Okay, is it done? Can we move to the B part? So in the B part, we need to find the x, which is the largest right angle triangle adjacent. Let's again label it. This is T1, T2, and this as T3. So from T1, I'm going to get this vertical height, which is sine 57 degree is equal to AB upon 5.8. So AB would be 5.8 times sine 57 degree, which is 4.86 centimeter. We can also find the length of CB. So for that, I'm using cos 57, which is adjacent upon hypotenuse. So BC is 5.8 times cos 57 degree. So 5.8 times cos 57, which is 3.16 centimeter. So we have AB, we have CB. Let's find out this BD. So from triangle 2, we have opposite AB just found. we need to find adjacent, which is BD. So I'll use tan 22 degree, which is opposite AB, 4.86 upon adjacent BD. So BD is 4.86 over tan 22 degree. 4.86 over tan 22 degree, which is 12.03 centimeter. So we have the hypotenuse of the largest right angle triangle here from T3 now, that CD is the hypotenuse of triangle 3 and CD is BC plus BD. BC is 3.16 plus BD is 12.03. So 3.16 plus 12.03, that is 15.19 centimeter, that is CD. Now we can use the Pythagoras here. Hypotenuse we got, we have one of the other side 8.4. So to find the x, I use the Pythagoras, which is hypotenuse square minus other side square. So that is coming out 12.656, 12.7 centimeter. So this x is 12.7 centimeter. Okay. All right. Let's comes to the question 3. We have ABCD is a square. We have the length of AP. So let's mention that AP 5 centimeter. We have QC 7 centimeter. We have PB, which is this one, that is 12 centimeter. We need to find a lot of things here. First, the size of the angle marked X, this value. Easy one, you can find. In square, all the angles that made by a square are 90 degree. All the angles are perpendicular. All the angles are right angle. Right? It is 90 degree. So isn't this ABP is a right angle triangle? You can write, since ABCD is square, hence ABP is right angle triangle. Therefore you can use, we have AP, we have PB, so I can use here, that is opposite upon hypotenuse. So sine x is equal to opposite upon hypotenuse. Sine x is opposite upon hypotenuse. So x would be sine inverse 5/12, which is 24.62, 24.6 degree. The length of AB, the length of AB. So I'm going to use the Pythagoras here. Using Pythagoras theorem, AB is root under hypotenuse square minus other side square, which is root under 119, and that is 10.9 centimeter. So this is 10.9 centimeter. Are you getting this? Find the length of DQ. DQ is here, and since we know that AB is 10.9 centimeter, it means that AB is equal to BC, which is equal to CD, which is equal to AD, right? And all will now become 10.9 centimeter, since ABCD is a square, and in a square all sides are equal. Okay, so this DQ is some part of CD, and some part of CD, which is QC, is given to you 7 centimeter. So I hope you get the link. So DQ would be what? CD minus CQ. CD, which is 10.9, minus CQ, which is 7, which is 3.9 centimeter. So DQ is 3.9 centimeter. Yes? Are you getting this? Yeah. In the very similar way, you can find the PD. PD, which is some part of AD. So D is also very simple now. AD is 10.9 centimeter, and PD is equal to AD minus AP. AD, which is 10.9, minus AP, which is 5. So 10.9 minus 5, which is 5.9 centimeter. PD is 5.9 centimeter. Okay. Find the size of BQD. BQD. Alright. BQD. This one. BQD. So to find the BQD, what I can do, I'll find BQC. I'll find BQC. Right. This triangle BCQ is a right angle triangle. BQC is a right angle triangle. Right. BCQ. You can see here BCQ is a right angle triangle. Are you getting this? B C Q is right angle triangle, isn't it? So if we find this angle BQC, the other part would be what? 180 degree minus BQC. So BQD would be what? 180 minus BQC, and BCQ, it is easier to find because we have the information of QC. We also know what is the BC. What is the BC? BC is nothing but 10.9 centimeter, right? So in triangle BCQ, I'll use tan BQC, tan BQC opposite upon adjacent, 10.9 upon 7. It will be angle BQC is nothing but tan inverse 10.9 over 7. And it is 57.29, 57.3 degree. This is 57.3 degree, right? Now BQD is what? Angle BQD. Therefore angle BQD is 180 minus angle BQC, right? A linear pair, angle on a straight line. So 180 degree minus 57.3 degree, which is 122.7, 122.7, which is approximately 123 degree. Are you getting this? All right, let's move to the next question. Question 4. Read the question very carefully. Try to get the information. In a house that is being renovated, two corridors meet at right angles. So which two corridors they're talking about? You can see the two corridors. The length here between them is 2 meter, and on the downside it is 1 meter. As shown in the diagram, workmen attempting to take a ladder around the corners get the ladder stuck when it is at an angle of 45 degree to each wall. 45 degree to each wall, like here and here. It's make an angle of 45 degree to each wall. So they are talking about both wall. It means that here also it is 45 degree. Get stuck when it is making angle 45 degree to each wall. By default this is also 45 degree, because this is 90 and this is 45, so this will be also 45, and this is 45 because it is stuck when it is making angle 45 degree to each wall. So that is wall 1 and wall 2. Determine the length of the ladder. We need this length of the ladder. Yeah, from the downside is 1 meter. That's right. So if you just get this one is 1 meter. That's right. This is 1 meter. So I'll also drop perpendicular from here, which is 2 meter. This is 2 meter and this is 90 degree. So this will going to help me to find the length of some part of the ladder A, B, C, D, E, F. Let's label it. So in triangle ABC, beneath the BC, right? Beneath BC. BC is the hypotenuse here in this triangle ABC. So we have opposite given. So I'm going to use what? Sine 45 degree is equal to opposite, which is 2, upon hypotenuse, which is BC. So BC is 2 upon sine 45. Sine 45 is 1 over root 2. So it is 2 root 2. So BC is 2 root 2. And in triangle BFE, again this is right angle triangle at F, and this is 45, so this will be also 45. Angle BEF is 45, and here I'm going to use, because I have the adjacent given, which is 1, so I'll use cos 45 is equal to adjacent over hypotenuse, which is BE. So therefore BE would be 1 over cos 45. Cos 45 is also 1 over root 2, so it is 1 root 2 meter. Now we have the length of the ladder. So the length of the ladder would be CE. And what is the CE? That is BC plus BE. BC is 2 root 2 plus 1 root 2. So it is 3 root 2 meter. If you want to get the actual value, that is 4.24. Okay, is it clear? Alright, let's take the next part. I need the new structuring of this question. This time the situation changed. Determine the length of the second ladder that got stuck when it was at an angle of 60 degree with the wall of 1 meter corridor. Wall of 1 meter corridor. It makes angle 60 degree with the wall of 1 meter corridor. It means that here it is 60 degree. This time it is stuck when it is making an angle of 60 degree with the wall of 1 meter corridor.